Okay, so what we're going to be going on to in the next chapter is called radicals. So if we're thinking about this, everything has an opposite function. Everything has some way to be able to undo an operation. So if we're thinking about what undoes addition, so if we have addition, and we're thinking about what do we use to undo it. So if we're adding 5, how do we unadd 5? We would use subtraction. Likewise, if we're multiplying something, we would use division to undo it. If we're subtracting, we would use addition to undo that. Or if we're dividing, we would use multiplication. So these things are like the opposite of each other. So when we made our reference sheet, we actually had to multiply the number by itself multiple times. So we have an exponent. So whenever we have an exponent, the opposite of doing that exponent is taking the radical of it, or the roots. So we're going to start working with using those roots, or using those radicals to undo exponential functions, to undo those exponents. So what we're going to label these notes as is nth root radicals. So I'm going to give you some definitions. We always start with definitions, so that's where we're going to start. And then we'll go on from there. So starting with some definitions. First definition I'm going to give you is square root. The square root, so for all real numbers, I'm going to abbreviate numbers. If a is squared and it's equal to b, so this is just saying any number squared is equal to something, then the opposite could be said that a then by itself without that square is equal to the square root of b. And we are going to do some examples, so don't worry, we always do examples. So our vocabulary term is here, and then the definition is beside it. The next thing that we have is the nth root. So we're not always going to have a square root. A square root is when there's no number on top of our radical symbol. Just so you know that this symbol means radical or root. So the nth root, then, for real numbers, so it starts off the same way. If a is to the exponent of n, so that could be 3, 4, 5, 7, 11, 102, is equal to b, so it's equal to some number, then a is equal to the nth root of b. Okay? So if I have something without any number up here above it, that just means it's automatically assumed that it's a 2, so that just means that I'm assuming it's a square root. If I have a letter there, like I do here, it's an nth root. So if there's a 4 or a 5 there, it's an nth root. It's the cubed root, the 4th root, the 5th root, anything like that. So again, here's our definition. And then here's our vocabulary term, and then the definition is after it. That out of our way. All right, the next thing that I have is some laws, but before we get to the laws, I do have one more definition I want to do so that they're all together. So an irrational number. An irrational number is a number expressed as a terminating or repeating decimal. So that just means that it's a number that keeps repeating itself. So it's like 0.444444. If we were to do 1 divided by 3, that's 0.33333333, so on and so forth. That 3 never ends. If it's terminating, it means it's something like 0.89, and that's just the entire number that it's given. All right, so moving on to some laws. For the laws, we're going to make a chart. So the first column is what is n. And we're using n in the sense of this particular form. And b is on the inside. So we're using this form at the top and the form that is on the inside. So n here and b on the inside. So this is the form we're using. So first column, what is n? The next column is what is b? And the last column is the real roots. So when we use radicals, sometimes you could get what's called an imaginary root. Imaginary isn't something that's real if we think about those definitions and what they mean. So that is why they're called real roots. They're something that actually exists. It's not an imaginary root, which we will get into later, but not quite yet. So if n is even, there are going to be 4 laws. The first one is if n is even. The second one will again be if it's even. The third one will be if it's odd. And the fourth one will be if it is odd. So for the first one, we're going to finish filling that one in. So if n is even, so that top value is even, and b on the inside is greater than 0. So if b is greater than 0, then you're going to have a positive and a negative real roots. So you'll have 2 real roots, 1 positive and 1 negative. The next one is if it is even and b is less than 0. In this case, you're going to have 1 real root and it is going to be positive. The third one, if it is odd, if n is odd and b is greater than 0. Oh, I messed this up. So you're going to want to erase that. If b is less than 0 and it is an even n, then there is no real roots. That was my fault. All right, so for number 3 then, if it is odd and b is greater than 0, then there is going to be 1 positive root. Mixed up the lines when I was trying to write it down and I was looking at my notes. For the next one, n is odd, and since it was greater than 0 for the last law, it's going to be less than 0 for this law. Then you're going to have 1 negative root. So here's the reason why. So if I have an even number on the top, so this is an example of the first law. Mark these as examples. So the example of the first law is if I have a square root of the number 4. My pen pen decided to stop working there for a second. So the square root of the number 4. That would give me what is supposed to be positive or negative 2. And the reason being is because if I go backwards, I would say that 2 squared is equal to 4. I also know that negative 2 is the same thing. Negative 2 squared would be like saying negative 2 times negative 2. A negative times a negative is a positive, and 2 times 2 is also 4. So both of these equations give me positive 4. That is why I have both a positive and a negative 2. Likewise, if I was to go and give you an example of law number 2, like we just looked at here, if I have a negative number and I'm squaring it, I am never going to get a negative number back out. And law number 2 says that b is less than 0. So I can't take the square root of a negative number because I can never get a negative number back out, because every time I square something negative or do something negative to the 4th power or an even exponent, I will never get a negative number back, because if I have groups of 2, so something, if I did 4, for an example, I could do 2 to the 4th power. So if I did 2 to the 4th power, negative 2 to be specific, that means that I'm still using negative 2 times negative 2 times negative 2 times negative 2. So I have a negative times a negative, which is a positive, times a negative, which does give me a negative, but I've still got another negative, making this a positive answer. That's why there's no real roots, but you could have an imaginary one, which, like I said, we're going to get to at a later time. So then the odd roots, it's the same idea. So if I have an odd root, I've got 3 and 4, law 3 and 4, I've got a negative times a negative times a negative, which would still give me a negative answer. Or if my b is greater than 0, so that would be law 4 here. And then law number 3, if I have a positive times a positive times a positive, that would still be a positive answer. So that is why these laws are written the way they are written. So we are going to go through some examples of how these things work. So let's look at some examples. So the first example we're going to go through, number 1, is going to be the square root of 49. Square root of 49 z to the 8th power. So example number 1, 49 z to the 8th power. There are multiple different ways to solve these. I'm going to show you 2 separate ways, so that way we're not getting too confused here. So like I said earlier, if there is nothing on the outside here, we're always going to assume that there is a 2 there. So looking at this, I need to know that a number times itself, so a times a, is going to give me 49. So if I wanted to, I'm going to go back to that reference sheet, and I'm going to find something in the perfect squares, because there's a 2 on the outside here, so I'm going to look at my perfect squares column. And I'm going to find where something is equal to 49, and that happens to be 7. So I know that 7 times 7 gives me 49. The next thing that I'm looking at is I have z to the 8th power, so that means I'm doing z times z times z 8 times. So that's 4, 5, 6, 7, 8. So all I've done is I've elongated everything. I found what times itself gives me 49, so 7 times 7 is 49. And then I just wrote z out 8 times because that was my exponent. So then once I'm here, I'm going to use the number on the outside and group them by that many. So since I have a 2 on the outside, I'm going to group them by 2s, but they have to be alike. So 7s are alike, and there's 2 of them. Then I've got 2 z's. I've got another set of 2, another set of 2, and another set of 2. I couldn't group a 7 and a z together because those aren't the same thing. So from each of these, I can then pull out one of them. And notice there's multiplication symbols between everything, so I'm still multiplying everything together. So 7 times z would just be 7z, but I still have 4 z's left. So my final answer will be 7z to the 4th power. So that's way number 1 of solving this. So this is way number 1. I'll label it way number A. Actually, I'll just write way 1 so that way we don't get ourselves too confused. So that's the first way we can solve this. The second way is I still need to know that something times itself is 49. And we already discovered that that was 7, so I can just pull out a 7. And I can actually divide this 8 here by whatever number's on the outside. So 8 divided by 2 is 4. So I know that I would then have z to the 4th power. Either way works. Either way is fine. If you prefer to write it all out, you can do that. If you prefer to just use division and find what root it is, so 7 times 7 would be the root of 49. You can do it that way as well. We're going to do a few more examples. So, example number 2. This time I'm going to have a negative 3rd root of 2a minus 1 to the 6th power. So if I was to use way 1, I would write out 2a minus 1 6 times. So 2a minus 1, 2a minus 1, 2a minus 1, that's 3, 4, 5, and 6. Once I have that, then I can group them in groups of 3. There's a 3 on the outside, so I'm putting these in groups of 3. And I've got 1 group and 2 groups. And this first group is a group of 2a minus 1. And the second group is a group of 2a minus 1. So I've got a total of 2 groups of them. So the answer would then be 2a minus 1 to the 2nd power. So that's my answer. If you want to use the other way, so that second way, then move it down here. Then I'm going to take 2a minus 1. I'm going to rewrite it here. To the 6th power. I'm going to use the number from the outside and divide it by whatever that number is. So 6 divided by 3 does in fact give me 2. So I'm going to have 2a minus 1 to the 2nd power. Now, notice I forgot something. There is a negative on the outside here. So I'm saying basically negative 1. And I'll use a different color so that way you can see it. So I'm basically saying negative 1 times whatever is on this part. So this is basically, this square root acts as parentheses. So it acts as a set of parentheses. So I've still got this negative that I'm going to keep on the outside. And that would be my final answer. We're going to go ahead. I'm going to do one more example with you. All right, so this one is just going to be a plain old number. So I'm going to have the square root of 81. Remember, if I don't have a number on the outside, I'm just going to assume that that is a 2. So I'm looking for what number times itself So what number times itself gives me 81? So again, I'm going to use my reference sheet here. This is why I gave it to you. And because I have a perfect square, I'm going to assume that it's going to be in my squares. I'm looking for a square root, so I'm going to look for a perfect square. So I'm looking for 81, and that is in fact 9 times 9. So I'm going to go back, and I can say that 9 times 9 is what my value is times itself to give me 81. That means that my answer then is just 9. Again, if you want to pair those off, you've got one pair, and that pair would be just a 9. All right, so I'm going to give you a few that you can do, and then you can check your answer with my answer. All right, so that first one, you're going to have a you try section. The first one you try is going to be the square root of 64. You're going to try the square root, how about the cubed root of m to the 6th power, n to the 9th power. And you're going to try the square root of 4k to the 4th power. So go ahead, give those a try, and then I'm going to come back and explain them. So try them on your own, pause the video, and then I'll come back and explain them. Okay, so when you're trying to do these, the first one, a times a, it's a square root. So a times a, that means that I'm doing 8 times 8. So you should have an answer of 8. The next one, I'm going to use the method where I'm dividing. So I'm going to do 6 divided by 3 and 9 divided by 3, which means that I would get m to the 2nd power and to the 3rd power, and that would be my answer for that second one. The third one, there's 2 different ways you can go about this, as well as the 2 different ways that I've already given you. So we know from the previous chapter that I can distribute in my 4. So that means that I would have 4 to the 4th power, k to the 4th power. And I'm still taking the square root of that. So when I'm doing this, I would then be able to do 2 things. I could say, what is 4 to the 4th power? And I know that I did that one, and it's 256. I found that right here, 256. So what I'm going to do is I can say, all right, well, I know that is in fact 256, k to the 4th power then. So I can do that. And then I can find the square root of 256. Sadly, I didn't give you the square root of 256 on here. If you would like to add it, it is 16 squared, gives you 256. So if you want to add that one on there, you're more than welcome to. So it would be 256, which is 16 times 16. And then I can write out my k 4 times. And then I can do my groups together, so pair them off. Remember, there's nothing on the outside, so I'm assuming that I have a 2. So I'd have 16 times k, which is 16k to the 2nd power. So that is the first thing that I could do. I could do it that way and do it where I'm pairing them together. Or I could have said up here, well, I know there's a 2 on the outside, and divide them both by 2, giving you that same answer. Either way, you would get the same thing, because 4 to the 2nd power is 16. 4 times 4 is 16. All right, so hopefully you got those correct. Hopefully you got the same answers as me. The next one that I want to show you, and we'll get into this a little bit more later, but I wanted to give you another example of something that you're going to see, is you might see something like this. You might get the square root of 81 over 64. This just means that I have the square root of 81 divided by the square root of 64. So the square root of 81, which I did up here in example number 3, I found was 9. So I would do that same thing, and I could say that that square root was 9. And then I just did in the you try section in that first one, I just did the square root of 64 is 8. So I'd have 9 over 8, and that would be the final answer. So I'm just taking the square root of the numerator and dividing it by the square root of the denominator. So I'm going to give you one more that you can try, so a you try. So for that particular one, let's do 49 over 100. So you're going to find what the square root of 49 is. So what times what times itself gives you 49. You can go and use the reference sheet if you like. We did the square root of 49 back in the very first example. You should have gotten 7. And then the square root of 10 would be, or 100 would actually be 10 times 10, which is 7 over 10. And I can't simplify that fraction, so I'm just going to leave it alone. If, in fact, you can simplify the fraction, you need to simplify the fraction. All right, so a few more examples, and then you're going to be set free from doing notes. There will be a few questions at the very end that you'll have that you need to try. It'll probably be 4 questions, 3 questions, something to that effect. All right, so the next thing, we talked about some terminating decimals. So sometimes they're not always going to come out as pretty as this, as whole numbers, as simple fractions that we can find. Sometimes they're going to be said, okay, what's the 5th root of 7 point, sorry, looked at the wrong one then, of 18.2. So these are going to be the ones that are irrational numbers. So we're going to label this as irrational numbers. So if in case you get something like this, you can just type it into a calculator. So I'm going to go back over to the calculator, and I'm going to type in the nth root. So I'm going to use this button right here below my arrow, the nth root, and then I'm going to type in that 5 and then 18.2, and it'll tell me what I get. And notice that it is a decimal, so my answer would be 1.787. Every time you do something like this, you are going to want to use 3 decimal places. So 1.787, always round to 3 decimals. So in the case that you're rounding, remember, if you have anything with a 5, so if the 5 follows that 3rd decimal, so an example is 0.785. If that is a 5, a 6, 7, 8, or 9, you're going to want to round up. So this is only being rounded to 2 decimals, but in this case, you round up. So if that last number before the 3rd decimal, if you want a better example, I'll say 7875. You're going to round up, so it would be 7.788. If it is anything less than 5, so if you have 0.787, 4, 3, 2, 1, or 0, you're going to leave it as it was, 787. Just a reminder on those rounding rules. So if it is greater than 5, round up. If it is 5 or greater, round up. If it is less than 5, round down, round it to the same thing. You're not really rounding down. You're not changing anything. So that's all you have to do. The same thing would happen is if I give you the example of negative square root of 62. So if I go and look at my list, I don't ever have a 62. In fact, if I'm looking closely enough, I go from 49 to 64. So I know that this isn't a perfect square. So I'm going to go back to my calculator, take negative square root of 64. So I'm going to hit the enter button so that that goes up. Then I'm going to do the negative square root and then type in 64. And it'll tell me what my answer will be. So it'll be negative 2.449. Let me make sure I typed that in right. 64, not 6. That was my bad. 64, so 62, wow. 62. Negative 7.874, that is what we should get. Negative 7.874. So that is how you're going to get those answers. So go ahead, do a few on your own. So you try. And you're going to try to do the square root of negative 15 and the cubed root of negative 15. Let's go and pause the video and try them. So when you do this, you should have noticed that when you do the square root of negative 15, you actually get undefined. That's because if we go back to our laws at the very top, we see that if I have an even n, so 2 was even, my root was 2, and my b was less than 0, which means there's no real roots. So that means that I don't have an answer. It is undefined. Or you could put no real roots. You could write either one, both mean the same thing. However, if you did the cubed root of negative 15, you do get an answer. You get negative 2.466. So the answer here would be negative 2.466, which this brings me to the fact that we haven't been doing this. So for this particular answer, for this one here, this one is going to be negative because I have the negative on the outside. For things like examples that we did here, these technically should both be positive and negative. I'm not going to be too stingy about this. It'll matter more if you go on to classes where you're doing calculus and you need to remember that you have both kinds of solutions. I just wanted to make sure that you are looking at this and that you do know that that is how that is supposed to be labeled. So, I'm not going to be too picky about it, but I did want to make sure that you had those examples and that you did know that's how it's supposed to be labeled. So, that being said, I'm going to give you 4 questions that are considered your exit ticket questions. You're going to submit these. It'll give you instant feedback if you're right or not. So, first question, you are going to do the square root of negative 10, the cubed root of negative 14. Do the square root of 121 over 4 and the fifth root of p to the 5th power. So go ahead and do those 4 problems. I know that you can do them. You've got this. Hopefully you have all of those notes down as well.